Introduction. Students, do you know what polynomials are? Polynomial is an expression of more than two algebraic terms. And can you tell which type of polynomial is this? Is it quadratic polynomial, sir? Correct. This is a quadratic polynomial. When we equate this polynomial to 0, we get a quadratic equation. Today we will learn about quadratic equations. Objectives. At the end of this lesson, you'll be able to explain quadratic equation, find solution of a quadratic equation by factorization, find solution of a quadratic equation by completing the square, explain the nature of roots. Quadratic equations. An example of a quadratic equation is, the name quadratic comes from quad, meaning square, because the variable gets squared, like x square. It is also called an equation of degree 2, because of the 2 on the x. The standard form of a quadratic equation looks like this. ax square plus bx plus c is equal to 0. The letters a, b and c are coefficients. They can have any value except that a cannot be 0. The letter x is the variable or unknown. Example on quadratic equations. We will now check whether the given equation is a quadratic equation or not. Solution. Here LHS is equal to x into 3x plus 4 is equal to 3x square plus 4x. So, x into 3x plus 4 equals x square plus 1 can be written as 3x square plus 4x is equal to x square plus 5. Therefore, we get 2x square plus 4x minus 5 is equal to 0. It is of the form ax square plus bx plus c is equal to 0. So, the given equation is a quadratic equation. Roots of quadratic equation. A real number alpha is called a root of the quadratic equation ax square plus bx plus c is equal to 0, where a is not equal to 0 if a alpha square plus b alpha plus c is equal to 0. We also say that x is equal to alpha is a solution of the quadratic equation, or that alpha satisfies the quadratic equation. The zeros of the quadratic polynomial ax square plus bx plus c and the roots of the quadratic equation ax square plus bx plus c is equal to 0 are the same. Solution of a quadratic equation by factorization. Let us learn to find the roots of the equation by factorization. Take an equation x square minus 9x plus 20 as 0. Solution. First, factorize the quadratic equation x square minus 9x plus 20 as 0. Find two numbers which add up to 9 and multiply to give 20. These numbers are 4 and 5. X minus 4 into x minus 5 is equal to 0. Now find the value x so that when these brackets are multiplied together, the answer is 0. This means either x minus 4 is equal to 0 or x minus 5 is equal to 0. So, x is equal to 4 or x is equal to 5. You can check these answers by substituting 4 and 5 into the equation. X square minus 9x plus 20. Substituting 4 gives 4 square minus 9 into 4 plus 20 is equal to 16 minus 36 plus 20 equals 0. Substituting 5 gives 5 square minus 9 into 5 plus 20 is equal to 25 minus 45 plus 20 equals 0. Remember these three simple steps and you will be able to solve quadratic equations. Example. Suppose we wish to solve x square minus 5x plus 6 is equal to 0. We factorize the quadratic by looking for two numbers which multiply together to give 6 and add to give minus 5. Now minus 3 into minus 2 is equal to 6 and minus 3 plus minus 2 is equal to minus 5. So the two numbers are minus 3 and minus 2. We use these two numbers to write minus 5x as minus 3x minus 2x and proceed to factorize as follows. From which x minus 3 is equal to 0 or x minus 2 is equal to 0. So that x is equal to 3 or x is equal to 2. These are the two solutions. Example. Now suppose we wish to solve x square minus 3x minus 2 is equal to 0. We are looking for two numbers which multiply to give minus 2 and add together to give minus 3. Never mind how hard you try, you will not find any such two numbers. So, this equation will not factorize. For this we need another approach. We will learn that in the next screen. Solution of a quadratic equation by completing the square. This is another way to solve a quadratic equation if the equation will not factorize. It is often convenient to write an algebraic expression as a square plus another term. The other term is found by dividing the coefficient of x by 2 and squaring it. Any quadratic equation can be rearranged so that it can be solved in this way. Have a look at this example. Rewrite x square plus 6x as a square plus another term. The coefficient of x is 6. Dividing 6 by 2 and squaring it gives 9. X square plus 6x is equal to x square plus 6x plus 9 minus 9 equals x plus 3 whole square minus 9. Example. Solve 2x square plus 20x plus 3 is equal to 0. Rewrite 2x square plus 20x plus 3 is equal to 0 to get x square on its own. 2 into x square plus 10x plus 3. The coefficient of x is 10. Divide 10 by 2 and square to get 25 is equal to 2 into x plus 5 whole square minus 25 plus 3 equals 2 into x plus 5 whole square minus 50 plus 3 equals 2 into x plus 5 whole square minus 47. We know that 2x square plus 20x plus 3 can be written as 2 into x plus 5 whole square minus 47. Therefore, we can rewrite the equation as 2 into x plus 5 whole square minus 47 equals 0. 2 into x plus 5 whole square is 47. Now dividing both sides by 2 we get x plus 5 whole square is equal to 23.5. Take the square root of both sides. X plus 5 is equal to square root 23.5 or x plus 5 is equal to minus square root 23.5. X is equal to minus 5 plus square root of 23.5 or x is equal to minus 5 minus square root 23.5. X is equal to minus 0.152. Three significant figures or x is equal to minus 9.85. Three significant figures. Nature of roots. The roots of the equation ax square plus bx plus c is equal to 0 are given by x is equal to minus b plus or minus square root b square minus 4ac whole upon 2a. Here, b minus 4ac determines whether the quadratic equation ax square plus bx plus c is equal to 0 has real roots or not. b square minus 4ac is called the discriminant of the quadratic equation. 1. If b square minus 4ac is greater than 0, then the quadratic equation has two distinct real roots. 2. If b square minus 4ac is equal to 0, then the equation has two equal real roots. And 3. If b square minus 4ac is less than 0, then the equation has no real roots. Example. Suppose we wish to solve x square minus 3x minus 2 is equal to 0. Comparing this with the general form ax square plus bx plus c is equal to 0, we see that a is equal to 1, b is equal to minus 3, and c is equal to minus 2. These values are substituted into the formula. It becomes x is equal to minus b plus or minus square root b square minus 4ac whole upon 2a, which is equal to minus into minus 3 plus or minus square root minus 3 square minus 4 into 1 into minus 2 whole upon 2 into 1. By calculating it, we get 3 plus or minus square root 17 upon 2. These solutions are exact. Did you know? Many people believe that Babylonians were the first to solve quadratic equations. In fact, Brahmagupta, AD 598 to 665, gave an explicit formula to solve a quadratic equation of the form ax square plus bx is equal to c. Summary. Let us summarize what we have learned. A quadratic equation in the variable x is of the form ax square plus bx plus c is equal to 0, where a, b, c are real numbers and a is not equal to 0. A real number alpha is said to be a root of the quadratic equation ax square plus bx plus c equals 0 if a alpha square plus b alpha plus c is equal to 0. The zeros of the quadratic polynomial ax square plus bx plus c and the roots of the quadratic equation ax square plus bx plus c is equal to 0 are the same. If we can factorize ax square plus bx plus c, a is not equal to 0, into a product of two linear factors, then the roots of the quadratic equation ax square plus bx plus c is equal to 0 can be found by equating each factor to 0. A quadratic equation can also be solved by the method of completing the square. Quadratic formula. The roots of a quadratic equation ax square plus bx plus c is equal to 0 are given by minus b plus minus is square root b square minus 4ac whole upon 2a, provided b square minus 4ac is greater than or equal to 0. A quadratic equation ax square plus bx plus c is equal to 0 has 1. Two distinct real roots if b square minus 4ac is greater than 0. 2. Two equal roots, that is, coincident roots if b square minus 4ac is equal to 0, and 3. No real roots if b square minus 4ac is smaller than 0.